Good morning to all. I am Dr. Kirti Kumar Jain, Assistant Professor of SIRT College, Bhopal. So, once again, I am in front of you. In past, I have discussed about the differentiation. So, we discussed about the definition and basics of differentiation. Then, how to find standard formula of differentiation, right? So after that, we have discussed some examples of differentiation using the differentiation rules and using the standard formulas. In last lecture, in last lectures, we have discussed about the successive differentiation. There, I have discussed first, second, third, and fourth differentiation. With some examples. Now we shall discuss the nth derivative, which is also a part of successive differentiation. So here we will find first, second, third, fourth, fifth, then nth derivative. So nth derivative, in order to determine the nth order derivative, find out some derivative of the given function up to the order of 3. You will see some pattern are following in the result. Now generalize the pattern by combining the term, and in the end use the knowledge of factorial to obtain the simplified result. Now some examples of nth derivative. Question number 1, find the nth derivative of sin x. So first we find here the nth derivative of sin x. Let y equal to sin x. Y1 means first derivative, y2 second derivative, y3 third derivative. So here y1 is equal to first derivative. Y1 means differentiation of sin x. Differentiation of sin x equal to cos x. Therefore y1 equal to cos x. So here we convert cos x into sin x. So therefore, we have to know that sin 90 plus x equal to cos x. Therefore, write in plus of cos x equal to sin 90 plus x. 90 means pi by 2. So y1 is equal to sin pi by 2 plus x. Now we find the second derivative. So again differentiation of sine equal to cos. So pi 2 is equal to cosine pi by 2 plus x. Now again cos pi by 2 plus x converted into sin x. So pi 2 is equal to sin pi by 2 plus x using the same rule. Therefore y2 is equal to sin 2 pi by 2 plus x. Similarly, we can find the third and fourth nth derivative. So third derivative y3 is equal to cos 2 pi by 2 plus x. Now it is also converted into sin y3 is equal to sin 3 pi by 2 plus x. Similarly, we can write nth derivative. So nth derivative yn is equal to sin n pi by 2 plus x. After finding the first, second, third derivative, we can find a series. Okay, using the series, we can write the nth derivative yn equal to sin n pi by 2 plus x. Now we take second example. Example number 2, find the nth derivative of x to the power n. Now, so let y equal to x power n, y1 equal to differentiation of x to the power n into x to the power n minus 1. Now find second derivative. y2 is equal to n is constant and differentiation of x power n minus 1. So n minus 1 into x to the power n minus 1 means n minus 2. Now find third derivative, n minus 1, n minus 2, x to the power n minus 3. Now fourth derivative, n minus 1, n minus 2, n minus 3 into x to the power n minus 4. Similarly, we can write the nth derivative using the similar way. Yn is equal to n minus 1, n minus 2, n minus 3, n minus 4 up to n minus 1, x to the power n minus n. And x to the power n minus n means x to the power 0. X to the power 0 is equal to 1. Any number of power 0 is equal to 1. Therefore, the remaining terms by n is equal to n minus 1, n minus 2, n minus 3 up to n. This is a factorial n. Now we can take next example. the nth derivative of e to the power ax. So let y is equal to e to the power ax. First derivative of e to the power ax is equal to a into e to the power ax. Now find the second derivative. A is constant. Again the differentiation of e to the power x. So a into e to the power x, or n a into a equal to a square e to the power x. Similarly, y3 is equal to a cube e to the power x, y4 equal to a to the power 4 e to the power x, y5 equal to a to the power 5 e to the power x. N is equal to a to the power n e to the power a x. Next, one more example we take here. Y equal to log x. So y1 equal to differentiation of log x equal to 1 by x, and 1 by x is also written as x to the power minus 1. So y2 is equal to minus 1, x to the power minus 1 minus 1 minus 2. y2 means second derivative, and third derivative y3 is equal to minus 1 constant, differentiation of x to the power minus 2 to minus 2 x to the power minus 3. y4 means fourth derivative, here minus 1 minus 2 constant terms, differentiation of x to the power minus 3 is equal to minus 3 x to the power minus 4. And fourth, fifth, sixth derivative, after write the nth derivative in similar way, minus 1 minus 2 minus 3 up to minus n minus 1 x to the power minus n. So by n is equal to minus 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 common from all the terms, therefore total number of terms equal to n minus 1, therefore minus 1 is n minus 1 times, so we can write as minus 1 to the power n minus 1, and all remaining terms are positive. So 1, 2, 3, 4 up to n minus 1 and x to the power minus n. Now yn is equal to minus 1 to the power n minus 1, and 1, 2, 3 up to n minus 1 is written as factorial n minus 1, and x to the power minus n is equal to 1 upon x to the power n. Therefore yn is equal to minus 1 to the power n minus 1 factorial n minus 1 upon x to the power n. This is our nth derivative of function log x. The assignment problem for the students. Thanking you.